Now we will study the variables, which are one of the most important objects, of course, since this is the one that you use for modeling, and this is also the one that you interact with inside the constraints. And before introducing the implementation of the variables, I would like to show you an implementation of a small constraints because it will allow you to understand better the implementation of the variables and the functionality that we need there. So the constraint that we will implement is the one that we use for all different constraints. Is the variable x must be different from the variable y plus an offset c. And so I call this constraint not equal. And as you can see, we extend an abstract class that we will see later. What is important there is that you have a post and a propagate method. Okay, and the post method will do a little bit the hookup. And the hookup means you will register to the events that you are interested to be notified whenever something changes in the domain of X or the domain of Y. So in particular, we would like to be notified when X is bound and when Y is bound. And what we mean by notified is that the propagate method will execute whenever one of these two events happens. So if X is bound to a single value or if Y is bound to a single value inside its domain, then we want propagate to be executed. And you see that the way it's implemented is we do the variable propagate on bind, and then we give this, and this is of course the object itself, so the constraint, which is an abstract constraint itself in argument. Okay, and the way it will happen is that the variable will store all the constraints that are interested to be notified when something changes inside the variable. Okay, so we move to the variable interface, and again, as you can see, it's an interface, so we have many ways to implement this interface, and we will split the functionalities and the method in three different families. First, you have the queries. What is the state of the domain of this variable? What is the minimum, the maximum, the size? Does it contain this value v or not? Then we have the update method, which consists in removing a value, assigning a value, and this is typically the method that we will use inside the implementation of a constraint, because the constraint is in charge of pruning, which means removing some values from the domains of the variable. So this is the method that we will use when we implement the constraint. And then we have here the hookup methods. The hookup methods means I would like this constraint C to be notified when something changes inside the domain of the variable. Okay, so that's for the functionalities. And you can hook up the constraint at different levels of granularity. There is when the domain change, when it becomes bind, this is this one, or when a bound of the domain change, if the minimum or the maximum of the domain change. And this different level of granularity will allow us to be notified really when it's necessary to optimize a little bit the efficiency of some of the propagators. So the representation is quite straightforward of the variable. You need, of course, the solver, you need the domain, and then you have the three lists of constraints that correspond to the different level of granularity that the propagator might be interested in to be notified when something changes. Okay, and we will call that the events granularity. And so remember the three types of event that we have is the value is lost, something has changed in the domain, the bound, the maximum or the minimum has changed, and it becomes bound to a single value. And so inside the specific implementation that we will propose to you of the invar interface, we will store inside three data structure, which are stacks. So just remember for now that it's a stack. It could have been a list. Okay, it's just a linear structure that will store all the constraints interested to be notified when something changes in the domain of the variable X. So if something changes in the domain of the variable X, we might need to notify all the constraints that are stored there. And by notifying, I mean really call the propagate method of these constraints. Like this. So inside the implementation, again, we have these three different stacks. And we also have the domain of the variable. And by default, the constructor asks for a minimum and a maximum. And it's a really a range. We consider that all the values between the minimum and the maximum will be part of the domain. And this is also the way we initialize the sparse set domain internally inside the variable. Okay. So for the accessor method, it's quite easy. We just delegate everything to the domain itself. Okay, you ask the minimum, I return to you the minimum of the domain. You ask the maximum, I return the maximum size, and so on. So everything is delegated to the domain itself. It becomes a little bit more interesting when we study the hookup methods. So if you ask propagate on domain change, we will simply push this constraint inside the corresponding list. So there is the on domain list, which are all the constraints interested to be notified when something changes in the domain of the variables. We push this constraint that you want to hook up on top of the stack. And we do similarly for the bind and the propagate on bound changes. We simply add them to the list. Okay. If you remember one of the previous videos, we have seen that there was a listener mechanism for the domains. This is the moment where we will use it. This is inside the domain, the variable implementation. Okay. When something changes inside the domain of the variables, and by domain I mean the real domain that is used by the variable, when something changes, okay, we want to be notified. We want to be notified because we need to do something. If one of the variable, the domain changes, we need to schedule all the constraints that we're interested to be notified. We need to schedule them inside the fixed point algorithm. And this is where it happens. Okay, so we have a domain listener that whenever the domain of the variable changes will be notified. And what it will do as a consequence is that it will take all the constraints interested by these changes and schedule them inside the fixed point algorithm, so inside the propagation queue of the fixed point algorithm. So we will iterate over all the stack of constraints and really schedule the constraint inside the fixed point algorithm that is executed. In the next video, we will study the constraint mechanism implementation and the fixed point algorithm as well.